Hi, this is Jeff West, and I'd like to give you an overview and a demo of TopLink Grid, which is Oracle's approach to using coherence as a Level 2 cache for TopLink, which is Oracle's distribution of the open-source EclipseLink project. JPA is short for the Java Persistence API. This is the Java standard way of handling object relational mapping. The programming model is very simple and is configured using Java Annotations or an XML configuration file. At design time, JPA allows you to map Java classes to schemas and tables in a persistence tier such as a relational database. At runtime, a JPA persistence provider such as TopLink uses the mapping metadata to retrieve entities from the database and present them as Java objects, as well as persisting Java objects into the database. In order to optimally scale applications that have a persistence tier, a certain level of caching is necessary. Within a single JVM, the scaling is easy. In this case, each application would have an entity manager with a Level 1 transactional cache backed by a shared Level 2 cache at the entity manager factory level in the JVM. However, as you add more nodes to your application, you now have several different JVMs, each with their separate Level 2 caches that need to be kept in sync. This is where TopLink Grid fits in. TopLink Grid is a new component of Oracle TopLink and provides a way for JPA developers to leverage the coherence data grid to scale applications. What's nice about the TopLink Grid approach is it combines the use of the Java Persistence API with coherence. That is to say that the programming model is the Java standard JPA model, but you're able to leverage coherence for the Level 2 cache. There's no need for a JPA developer to learn a new API to scale their applications. The integration is fairly transparent, and we'll take a look at it in the next few slides. We call this JPA programming model backed by coherence, JPA on the grid. So, TopLink Grid represents TopLink with coherence as the Level 2 cache. The cache appears local to each node, but is actually distributed across the coherence cluster. Coherence manages the high availability of the data while enabling each node to have a consistent or coherent view of all of the data in the cluster. TopLink Grid enables you to create JPA applications that are highly scalable and reliable using coherence's proven data grid technology. TopLink Grid has three modes of operation that can be configured per entity type. The first is called Grid Cache, which is a simple replacement using coherence as the Level 2 cache in TopLink. With Grid Read, we go a step further by translating queries into coherence filters, which are executed on the grid, thereby leveraging coherence's very fast parallel queries. Finally, with Grid Entity, we support both reads and writes directly to the grid. This allows us to batch small updates and writes to the database in larger transactions. Let's take a closer look at each one of these strategies. First, we'll take a look at the Grid Cache strategy. Let's step through what happens when we perform a read. A query is performed, either a JPQL query or an entity manager find by primary key. A primary key query will go to coherence and do a get by primary key. If you find the object, it's simply returned. However, if the get returns null or the query was a JPQL query, then the database is queried. So for all JPQL queries, we do hit the database with a select statement. We are just using coherence for primary key queries. If we do query the database, then we perform a select, we build the objects, and then we put them into coherence, and then return them to the application for use. And this is how we populate the coherence cache. Coherence is also leveraged when processing database results. When SQL is executed by EclipseLink, EclipseLink constructs the JPA entities from the JDBC result set, but first extracts primary keys from the result set and checks the cache to avoid object construction cost. So even if SQL query is executed, coherence can still improve application throughput by eliminating object construction costs for cache entities. With the Grid Cache strategy, entities are written directly to the database. First, an application will persist an entity using standard JPA. The new or updated entities are inserted or updated in the database, and the transaction is committed. Once the transaction is committed successfully, the entity is then put into the coherence cache. If the database commit transaction fails, then the entity is not put into the coherence cache. Next, we'll take a look at the grid read strategy. With grid read, queries are a bit different. An entity manager find operation will result in a get on a coherence cache using the primary key. However, JPQL queries are translated into coherence filters to retrieve objects from coherence. In this case, the database is not queried. If coherence is configured with a cache loader, then an entity manager find may result in a select on a database, but by default, JPQL will not. You do, however, have the option of overriding this behavior by using a query hint with Eclipse link. Using this strategy, you can completely offload reads for static data from the database. You would, of course, need to warm the cache by populating it with the required data. With the grid read strategy, writing objects is the same as with grid cache. First, an application will persist an entity using standard JPA. The newer updated entities are inserted or updated in the database, and then the transaction is committed. Once the transaction is committed successfully, the entity is then put into coherence cache. Finally, we'll take a look at the grid entity strategy. With grid entity, queries are the same as with grid read. An entity manager find operation will result in the get on the coherence cache using the primary key, and JPQL queries are translated into coherence filters to retrieve objects from coherence. And the database is not queried. However, you can use a query hint to bypass applying the filter to coherence cache and go directly to the database. However, writing objects with grid entity is very different. Grid entity allows you to do write-behind caching to the database in order to group smaller writes or updates into larger transactions. When an application commits a transaction, Eclipse link puts entities into coherence. Then, if a cache store is configured, then coherence will write the changes to the database, either synchronously or asynchronously. If you are doing write-behind or asynchronous writes, it is important to understand the constraints in the database, because grid entity does not ensure that objects are written to the database in any given sequence. And, since writes are asynchronous, your application would not be notified in the case of a write operation unable to be committed. Next, let's take a quick look at how you configure TopLink Grid. Configuring JPA entities is simple and straightforward. You can either use Java Annotations or an external configuration file. TopLink Grid makes use of the JPA customizers. These can also be configured using either XML or Annotations. There are 3 different customizers for TopLink Grid, mapping to each of the 3 strategies we covered earlier. In addition to configuring your JPA entities for TopLink Grid, you also need to define your coherence cache configuration. Coherence uses named caches to define instances of maps that are available to your applications. By default, TopLink Grid will look for a named cache using the name of a JPA entity, such as address, parcel, or shipment. So, you need to define a cache mapping with your cache name for each of your entities, mapping it to a cache scheme. Each named cache is mapped to a cache scheme, which defines how data will be managed in the coherence cluster. The cache scheme is a template for the instances of named caches. Many instances of named caches can be mapped to the same cache scheme, but each named cache is different and independent of the other defined caches. Here we can see that I have defined a cache scheme called grid cache, and I am mapping the shipment, parcel, and address entities to this cache scheme. The configuration for the cache scheme shown here is for a partitioned or distributed cache with unlimited in-memory storage. You have the option of configuring partition caching, replicated caching, and or near caching in your cache scheme, and all of the configuration options you have for caching in coherence are available when you're using TopLink Grid. I'd also like to take a minute and describe some of the deployment models and topologies that coherence offers as it relates to WebLogic Server. Coherence and data grids in general are designed to be a place of storage outside of the JVM where an application is running. And this is so that you can scale that tier, that data grid cluster, separately from your application. So in the case of an application server, What you would typically find is that you would have one JVM for your application server and one or more JVMs for your cache servers. And again, this gives you the benefit of being able to scale them independently. So if you find you're running out of storage in your cache cluster or your coherence cluster, you can add more nodes there or more storage there. And if you find that you're running out of horsepower or compute power at the application server level, you can add nodes there independently of your data grid. We would call this an out-of-process topology because the storage-enabled nodes, where coherence is storing data and operating on that data, are located out of the process where the application is running. And this is the default recommendation due to the flexibility of this model, again, so that you can scale the tiers independently. You also have the option of deploying coherence into the same JVM where your application or application server is running. In this case, your application or application server and coherence will be sharing the same threads and sharing the same heap. This is an easy way to deploy an application for a demonstration or in a development environment or on your local machine, but this is not something we recommend for production. With coherence, you also have the option of having what's called a near cache, where you still have two separate tiers for your application server and cache server or cache cluster, but the most recently used data for a particular entity, if you're thinking of JPA, or a session, if you're looking at session state persistence, a copy of that is stored in the same process where the application is operating on that data. A good case for this would be for maintaining session state for web sessions. Typically, you would have a load balancer that has affinity to one particular application server. And in that case, that application server will be doing multiple operations on the session objects and session data as the user goes through their web session. That's an ideal case for a near cache because the only node that should be accessing that data, in theory, will be the node where the session is pinned. Another example for this is in TopLink Grid and for JPA. If you're manipulating one entity multiple times as part of one application flow, then you wouldn't have to go across the wire to access that data or persist that data into the tier for each operation that you make on that object. So if you have an out-of-process or a near-cache scenario, you have to point your application at the coherence cluster somehow. With WebLogic, we offer a couple different options. First, you can provide a coherence cluster reference in your WebLogic deployment descriptors. In this example, we have the WebLogic application XML, that's the deployment descriptor for an EAR file. However, this element is also available in the WebLogic.xml for WAR file deployments. Using this element, you can specify the name of coherence cluster that is defined within the WebLogic domain. And then the WebLogic application server will interpret this deployment descriptor and inject the appropriate coherence configuration such that your application can talk to the coherence cluster. You also have the option of using the Tengasol coherence override XML file, which is what you would find in a non-WebLogic environment. So that wraps up the overview of TopLink Grid, and in the next section we'll show a hands-on demo of some of the concepts that we've covered in this video.